neutral ground again. Okay, so that's the point at which the digger stops digging. It's also to determine, if you're looking at contours, the contours sort of come along like that. And the ones we have to redesign are what we call the design contours, which will be on the batter slopes. These are all, it's a little bit not level, but these are all supposed to be properly level. So the first thing we need to do is determine what area of this is going to be, shall we say, fill, and what area is going to be cut. The fill area is going to be the bottom part of the platform, so it's going to be down here somewhere. And the cut area is going to be up here. The next thing is to determine what the batter slopes are. Batter slopes are always in terms of the vertical direction and the horizontal direction. And for simplicity, we're going to make ours 1 and 1 and 2 and 1. A little story. When you're doing engineering and you're in a design office, now a lot of you will end up in the design office. Some of you won't. You'll be on site and you won't have to worry so much about this person. I guess it could be a female, but I don't think so, because most of them have always had big beards and they've been a bit scruffy and untidy, and no one really talks to them much, and they smell a bit and they turn up to work late and all sorts of things, and they get away with everything. You're wondering who I'm talking about, don't you? It's not me, I promise. It's someone called, this is all on camera, isn't it? Oh, it's brilliant. I'm going to have them all ringing me up and beating me up now on the past friends. They're what we call geotechnical engineers or geologists, okay? They love drilling holes in the ground, and they love coming and changing that batter slope design. And look, you could be a structural engineer with the best mathematical brain in the whole country, but you still need a geotechnical engineer to tell you what these slopes are. All right, sounds weird, but that's what a lot of structural engineers actually do, a double degree, and they get qualified in geotechnical as well, just to wipe that person off the planet so they're away from their designs. Because below ground is geotechnical and geology, above ground is structural engineers, right? That's basically the ground line is where they don't meet. From my point of view as a designer, I had all sorts of trouble with these guys. So these guys can actually come along and go, oh, can you change your cut to 1.3 to 1.4, and your fill can make it 2.2 to 1.6. You might not think that changing a batter slope matters much, but if it's 30 kilometres of road and the batter it changes, think of all the extra fill you're going to have to get and how badly out you're going to be with the cost. Just because he's done that. And you can't argue, because they're the person who's signing off the drawings. I can do all my calculations I like, but if that comes in late, I'm in trouble. But for the simplicity of this drawing, I'm going to make it 1 to 1 and 2 to 1. Now that person's going to come into play further on down the line in my lectures, by the way. So anyway, I'm going to show you how to do a 1 to 1 and a 2 to 1. Right. We're going to need a little scale bar up here because I don't have a ruler, so let's do what you guys are supposed to do on your locality plans on me. Let's call that 1 metre apart, each one. And I'll use that just to take some measurements. So if this one here is 1 to 1, that means we're going uphill. As we go along one, we go up one. As we go along one, we go up another one, and another one, and another one. But in plan view, looking down on that, that is also going to be 1, 1, 1, 1, isn't it? And that way it's going to be 1, 1, 1, 1, and that way it's going to be 1, 1, 1, 1. So it's quite easy to do the cut. All we do is we offset 1. There's no disputing that. There's nothing that we have to actually think about. It's 1 in both directions. So we can offset. Now we're going uphill as we're doing this. We haven't put a level on our platform. Let's put a level on our platform. Let's make it 19. So our platform level here is 19. So the next one up is going to be 20, 21, 22, 23. Okay, now we play a little game called Join the Dots. We'll start with 20, it's here, 21, 22, 22 again, 21, 20. Anyone know where it's going to touch the platform? 19? There. Three is not needed. So it's me. Anything outside of that red line, I can now delete. And here's something that you're all going to forget because it's about 3 weeks away. Anything that is a black line or a existing contour inside the platform design, we also delete. So we'll do a quick check. The now I've done this wrong. Let's have a look. Twenty-three goes around like that, doesn't it? That's 22. 22, 21. No, that's 19, 20. 21, I think there was another one there, and then there was the 23 that went up through here. 23, 22, that's it. So if we follow the 22, it goes along here, and it comes back out the other side. The 21 goes along around here and out the other side. 20 goes along around the platform and back up the other side. The 19 is on the platform itself. Now we're going to do the fill. Now with the fill, we're going downhill. We go along 2, down 1. Along 2, down 1. Right? Along 2, down 1.
Why the difference?
You need to join a company and ask the geotechnical engineer that, and he will take you aside for the morning, shout you a cup of coffee because no one's ever talked to him, and he'll explain the intricacies of soil properties and why a fill slope is normally on a different batter to a cut slope. In plain English, this has to maintain some weight coming down, so therefore that should be, I haven't drawn it properly, but it should be a steeper slope to maintain that, whereas here you're digging into a bank. Depending on the qualities of the soil, you can go quite steep. I've seen half to one before. Right? If it was sand, obviously you'd have to, it would be a different thing altogether. So if you study hard and do geotech as your main elective here at Unitec, you'll find that you're on a path to quite a good career, because it's not something everybody takes at Auckland Uni. but they're a high demand because everybody's got to have one in the office because they have to sign all these, all the soil reports off and all the designs off from the ground down. It's one of the advantages Unitec has got over Auckland Uni, actually. So getting back to the cut and the fill, we've got a design here of 2 to 1, 2 to 1, 2 to 1. You'll notice my assignment is also 2 to 1, 2 to 1 and 1 to 1. So here's our platform. We go along 2 and down 1. So from a plan view, we're going to have to offset 2 this time. Right, so it's going to come along, down, and around. I'm using the wrong colour, sorry. Down and around. Hopefully we'll get one of these blues that work. No, it's just like the Blues rugby team. It's fading. Right. Well, that's good for the ears, isn't it? Okay, so we're looking at 18, 17, 16, and there'll be a 15 around here as well. So we have to pick the points where they touch, so there'll be 18, 17, 16, 15. And you can see with this fill, because the slope is more horizontal than vertical, it's probably going to be something like this. Okay, now that's probably not correct coming back in here, it's probably going to be something like that and that and sort of over there like that. What if I was to draw these on here like that? That's what I call a butterfly flying into the sun, because it's got one thing like that, okay? Okay. It's also what I call the butterfly wings. Normally it's not like that, normally it's just a bit bigger on one side. And I call these the butterfly wings. The real name for them is the point at which the ground, the design touches the ground. The real names for them, and I want you to put this on your assignment, is top of cut and toe of fill. Now, there were students who didn't get full marks for their topo last semester, and they're like, well, you know, what's wrong with mine? I put all the notes on, and I said, but you put top of bank and bottom of bank. That's not the true names for them, all right? The other thing we have to do is we have to remember, you've all forgotten of course, on last week, and I said there was batter slope symbols that needed to go on your assignment too. The batter slope is the top of here and the top of here. So batter slope's symbol always starts at the top of any bank. So if it starts at the top of the bank here, it's going to go around like that. And that's what we call the batter slope symbol. Please have a look on assignment 1 for the symbols. On this side, the top of the bank will be the platform itself. Now, a number of things are going to happen with your assignment. This piece here is going to be rather crammed up, and it's going to be rather tricky to get all your different labels on there. This piece here is going to start going towards the wetlands. So in assignment 2, you're going to find that that's heading towards the wetlands. And that means you've got an environmental issue, you've got a structural issue. It's also going to head towards your tree. So you're going to have to come up with some arguments and thoughts, some notes for your drawing, and it's going to have to be included in your design report as well. So what this is, what this assignment is we start off with a simple existing site plan. It's pretty simple and basic. There's a few trees, a bit of a path, a design going on there, survey pegs. Then we do a long section, which we will do next week, and we're going to discover some other things that aren't quite right that we may need to put on our drawing in the form of a note. Then we're going to do our design batter slopes, and come up with this line here, and that's when you're going to get extra problems. And then I'm going to ask you to do 2 sections through here, not long sections, just 2 sections, and you're going to discover other things as well, which are not right or that need further investigation. So at the end of this civil section, you would have done a complete design of a platform on a site, which you can kind of almost look at, and you can come up with a lot of issues to talk about on your design report. I get students in week 6 go, I've got a week to hand in a design report, I've got no idea what I should be saying. I've just mentioned a number of things just today, okay? The design report is not just on the civils, because we're obviously going to be doing a bridge. So there are other issues with the bridge. We're going to be driving piles into the ground in the wetlands, which causes other problems. And we're going to be bringing some foreign material onto site as well. So just to make sure, that's a very, very simple design. 19.0, 1:1, 2:1. I've got an AutoCAD drawing there on Moodle. I'd like to open, I'll make it available now. And I want you to have a bit of a go